Welcome back to the OpenShift TV coffee break this morning at 10 a.m. European time. It looks like it's 3 a.m. in the night for some of our guests. So big shout out to Chris. We're going to introduce all the guests in a few moments. Let me please introduce myself. My name is Natale Vinta. I'm Product Marketing Manager here at OpenShift TV. And I'm together with my fantastic co-host, Fabio. Fabio, how are you?
Good morning, everyone. I'm Fabio, a solution architect for Red Hat, and here co-host with Natale these fantastical sessions.
All right. For the people that doesn't know what is OpenShift TV, Coffee Break is a weekly show where we talk about OpenShift, Kubernetes, Cloud Native in a web TV. This is a kind of a EMEA time zone-like show. So I'm very happy to have today our super special guest. Let me introduce first our special guest from another time zone, which is Chris. Hey, Chris, how are you?
I'm doing fine. How are you guys?
All fine. Thank you for joining us so early in the morning. This is special kudos to you. Chris is together with Hans-Peter. Hey, Hans-Peter, how are you?
Hi, I'm fine. I'm fine. For me, it's pretty good time in the morning, so everything's great.
That's great.
So you are not doing after hours?
No.
In fact, Hans-Peter looks smiley. I see the lights in his face. Well, also Chris is very, very smiley. But Hans-Peter looks a lot more, I don't know, more. He has more rest in his eyes, for sure. Well, folks, do you like to introduce yourself so the people know who are you and what you're doing and what we're talking about today?
Yeah, sure. I can go first. Like you said, my name is Chris Cranford. I'm the lead engineer on the Debezium project here at Red Hat. I've been with Red Hat for almost 7 years. And most of that time has been working on actual Debezium and change data capture. So really nice to be here and hope to be able to kind of share with you guys what Debezium is and why it's important and how it's really kind of shaping the CDC landscape in a really positive way.
Thank you.
Yeah, and hello, my name is Hans-Peter. I recently joined Red Hat, so basically pretty much 3 months ago as a developer advocate. I'm working in the team of Natale, lots of great other colleagues in there. And my relation to Debezium started a couple of years ago already. I was back then also starting to get involved into Kafka and the whole ecosystem and things like that. And from then on, I think it's pretty much about 5 years now that I have looked into Debezium for the first time. And I'm really happy that we can join this show and share it with the rest of the community.
Fantastic. Thank you, Chris. And thank you, Hans-Peter, for the introduction. Because today's topic is really Debezium and change data capture, which is a pattern, right? We noticed in the IT community, in the market, that this pattern is getting a momentum. That's why we invited you to please explain us why this momentum and what is really this pattern. But before we go into the technical detail, Fabio, I'd like to say hello to our YouTube and Twitch attendees, people watching us. Thank you. Can you please write in the chat where you are attending? Because we see, this is a show that arrives to many countries. Let us know in the chat if you want. And please, if you have any question about Debezium and change data capture and everything, send the question in the chat. We're going to bring the question to the speakers today. So, folks, what's change data capture and what's Debezium?
Yeah, sure. Let's start into that. So we can dive right in, and we brought a couple of slides, of course, that should help you also on the stream a little bit. So Debezium, I think, is best described as an open source change data capture platform, and it is basically supporting a family of different databases. We come to that in the next couple of slides. It is used to actually read from a database's transaction log. It has a couple of nice features. It allows to do, for instance, snapshotting, meaning that you can when you start initially to work with your data and you want to expose it to other services, you can take a so-called snapshot, and this brings all the existing data in your database into different systems. We come to that a bit later, how we can do that, because there are different ways to do it. Most often it's done propagating these changes through Kafka. You can filter it. It has also, since not too long ago, a really nice web-based UI that you can use to configure different types of source connectors that you want to run. And it's fully open source. It has a very active community. And I think Chris can in particular add a couple of more notes here regarding also different types of really large production deployments that they see, and add here a couple of more input.
Yeah, sure. So, I mean, from the community side, just to kind of point this out, we have over 400 contributors, individual contributors to the upstream project already, which is really, really amazing. So, we do have that vibrant community. A lot of people are constantly engaging with one another through the mailing list, through our chat, and other avenues. So, really, huge shout out to our community for really helping support us through this project and really helping us, add new features and regression testing and so much of that stuff. So that's really, really great. In terms of large production deployments, we do have a number of users that are using the project both commercially, but then also just from the community perspective. We have one large retail customer I know of specifically in Brazil that's using the newly released Oracle connector. They have been using this now for about, I believe, 6 to 8 months when it was going through its incubation period and things like this. We also have other big, large deployments. I know there's a discussion going on with some customers in Italy. We have some customers in India that are also looking to use Debezium. So it's really, really touching base on the entire global market with lots and lots of banks and postal services, retail vendors are really taking use of the project and really trying to scale it out and take advantage of what we offer through CDC.
Yeah.
And then I guess I can talk about this. And then, so in terms of connectors with Debezium, the biggest thing here is that each of these databases, they have their own format. They have their own way in which we have to kind of interact with the databases to get these changes. And so, it kind of means that from a Debezium's perspective, we have to integrate with each of these in their own way. So we have a host of database vendor specific connectors to be able to integrate with all of these database vendors. But despite needing to have a database vendor specific connector, we do have kind of like this uniform connector framework that we're able to use to be able to leverage a lot of those features that Hans-Peter had talked about previously, things like snapshotting, things like filtering. And so really kind of the benefit here as we are working with these different databases, with whether it be Oracle, whether it be Cassandra, whether it be MySQL, really this connector framework that Debezium brings to the table allows you to be able to kind of focus specifically on ingesting those change events using the APIs that database requires us to integrate with. And so we'll kind of talk about and touch on this a little bit later, but not only just using the connectors themselves does this make this really important, but it's also important from the perspective that if you are wanting to integrate or write your own connector, you can actually take advantage of this common connector framework for this as well. I don't know if you have anything else to add there, Hans-Peter?
No, that's fine. And I think what we should definitely touch upon here is the two fundamentally different ways to do change data capture and integrate with databases or data stores in general. And so here on that slide, we tried to summarize that a bit, because at one point, remember, you could think, well, why do I need that? Why can I not just do and leverage a query-based approach, basically meaning you find a way to come up with a SQL statement that allows you to check what has changed since you last queried a particular table. And that would be this query-based approach. But when you think about it in a little bit more detail, this approach has several limitations, actually, when you compare it to what Debezium does, namely integrating with the TX log of a data store. And so when you think about query-based change data capture, you would basically poll at certain intervals your database and particular tables in that database. And this would, first of all, mean you have a certain overhead because you're executing like any other client, different usually select statements against certain tables at certain intervals. So that's overhead, definitely. And what that also means is that you cannot really capture all the changes. And there's two things I think to highlight here. One is, think about that maybe something changed and changed again within your polling interval, then you might lose one of those changes because you haven't seen that. Why? Because it happened during the poll interval. Another thing that's usually hard to do is to capture deletions, because how would you easily query for something that has been there once but isn't there any longer? Also, very often you want to understand, okay, not only how does my data look like right now, but what was the previous state before a particular change. And also that is something that you cannot directly do with a query-based approach. And so essentially all those things that are hard or even impossible to get right with a query-based approach become possible when you directly interact with the transaction log of a data store. And this is exactly what all the Debezium source connectors that we just mentioned earlier for those different types of data stores are doing. So they can do all of these things in that regard. Do you want to add something here, Chris?
Yeah, I just want to point out the one point here about the transparency. What's really, really important, at least for me, is that by using Debezium and actually using the transaction logs to being able to do this log-based CDC approach, it really prevents you from needing to have to like manipulate your data model. You don't want those two things to necessarily be integrated, because going back to what you said, if you're wanting to do this polling interval, you're going to have something in your data model that you're going to use to be able to know whether or not from this timestamp to this timestamp, what records have changed. And when you start kind of mixing those concerns, it creates this really kind of like unnecessary coupling that, at least for me, I really dislike. And I think most people would agree in this regard. So being able to use a log-based approach really kind of gives you the ability to being able to not only capture all of those individual changes as you spoke about, but just really being able to allow your data model to focus on what it's meant to support in your business application without really integrating concerns that you need inside that business model for change data capture.
Yeah, Chris, what you are telling I think, is a great concept in the world of microservices, where the loosely coupled integration are key. So keeping the communication between microservices without any need to couple with a specific data model is great, because it allows to and correct me if I'm wrong, to apply all the patterns to related to the deploy as soon as possible stuff with the lowest impact on the other surrounding microservices that specific one is going to be integrated.
Exactly. And I mean, and we'll kind of touch on this a little bit later when we talk about the
Okay.
Outbox pattern. But that's also really, really important, of being able to not only, with the Outbox pattern, not only are you trying to keep your data model separate from a microservice perspective, but you're also trying to make sure that that data model isn't being leaked from one service to another. And using the Outbox pattern, which we'll talk about later, is a really good way of being able to prevent you from doing this by having a particular model that you want to use for your eventing components that you can morph independently from your data model itself. Absolutely.
Right. Yeah. And so remember, we talked about that we have different ways to deploy or to use, in fact, Debezium. And I think still, correct me if I'm wrong, Chris, but still the most common way of doing it in the wild is still by using it in the original way that was supported from the very early days of Debezium, namely that you use it within Kafka Connect. So you have these source connectors for Kafka Connect that are, again, specifically written for these different types of data stores, and you run them within a Kafka Connect environment. And then those changes are propagated into Kafka topics. And what you see there is that you have essentially a one-to-one relation between a table in a database and a topic in Kafka, where you would find all those changes that happened to a particular table. And then from Kafka, once it's there, you can work with different types of sync connectors and feed any of these change data events into your target system of choice. And here we have just a couple of those that are pretty popular listed here. So think about bringing certain changes into Elasticsearch, where you might want to build some kind of full text indexing solution, or think about that you use Infinispan as a cache, and you can then employ those change events to update your cache, or to initially also warm up your cache in that regard, or in general use any kind of JDBC sync connector to propagate that further in data warehousing infrastructure and things like that. And again, you capture inserts, updates, and deletes there, and they are propagated in exactly that way using Kafka topics in this case. But that's, of course, not the only way to use Debezium. Later on, there were more ways of working with Debezium in totally different scenarios. And another common one these days, I think Chris can highlight upon a little bit, is the so-called either embedded engine, or you use something called the Debezium server.
Correct. So, like you said, we've talked about Kafka Connect, but and you're correct, 90% of most of our users are using Debezium within Kafka Connect, but with the embedded engine, this is pretty much taking Debezium as a library, and it allows you to be able to kind of embed the Debezium engine itself directly inside of your application. You may have specific requirements as to why you might want to do this. For example, you might need to be able to interact with those change events at a very, very, very low level. A good example of this is the Apache Flink CDC connectors. They actually use the embedded engine inside of their framework to be able to capture those change events, manipulate those, and emit those events using their framework programmatically. But then there's also another component called Debezium Server, and this is using the embedded engine, but in a ready-made runtime environment. It's kind of very similar to Kafka Connect. It's meant to kind of fulfill the same role, but with a slightly different focus. It's really kind of designed to send these change events out to other messaging infrastructures. So for example, we have adapters for Apache Pulsar, Amazon Kinesis, Redis, Google PubSub. We even have one for Kubernetes Knative eventing. So you could really kind of harness the power of Debezium source connectors and really be able to kind of integrate with really any messaging platform, which is really, really cool, because at the end of the day, we want to bring Debezium to the largest audience possible. And being able to have these other ways of being able to run Debezium has been extremely crucial. And the Debezium server implementation itself in particular has become quite popular as of late, as more users are finding that it really opens up these additional alternatives with working with other message infrastructures, if you happen to not be a Kafka shop, for example.
Right. Yeah, and so there is, just as a hint, there was not too long ago, Chris showcased essentially this Debezium embedded engine in one of the recent Quarkus Insight episodes. So there's the link to that if you want to look into that. He does essentially the whole session is basically a live coding session where he nicely shows what it would take to use the Debezium embedded engine in a Quarkus application. It's a really nice way of seeing how this actually works. Essentially, you include it as a dependency into your project, and then you are ready to go and start to use that and can interact with those change events and literally do anything you want in your application to these change events. With that, so we mostly were talking so far about the technical foundation, what it basically is, how this log-based change data capture approach works. But besides the technical foundation itself, when you start thinking about the different ways that you could use this change data capture for various different use cases in the wild, you will really see that it opens up a lot of interesting scenarios that can be built upon this change data capture idea. And there's just a couple of those here listed in a tweet here by Gunnar. So it's about simple cases are replicating data between two systems. But again, we mentioned that, okay, why do you do that? Maybe you feed search indexes. You want to update search indexes, a full text search engine, maybe in Solr or in Elasticsearch or wherever. Maybe you have a cache. You need to warm up the cache. You need to invalidate the cache due to all of these changes that are happening elsewhere in your data store. And that's all very valid use cases that become possible in a pretty straightforward way, I would say, thanks to this really nice idea of change data capture in that regard. Also, microservices architectures, very often you need to somehow communicate changes happening in one particular service to other services. And here we also see later, Chris also mentioned it, one particular so-called CDC pattern that helps in that regard a lot, namely the Outbox pattern. And then there are a couple of others. So basically what you can see CDC also as this giant enabler, as it says here, and it sets free your data that was originally as if it was locked away in a database and you could not easily get it out and had probably a tough time, because think about all those legacy systems that you might not be able to touch. Maybe you don't have the source code. Maybe you are not allowed to touch the source code for that system and it's just running, but still you want to build new functionality, new services around it. And that this is how you can then tap into all the changes that are happening in the database of such a legacy application and then propagate it to any downstream consumer that you want to use. Yeah, maybe a few insights here. Maybe Chris wants to explain a little bit how the actual payloads that Debezium generates basically look like.
Sure, absolutely. So each of our Debezium events, in kind of, if you think about this from a relational table perspective, there is a key and then there's some payload that comes along with each of these events. Generally, we map the key that's associated to these events to the table's primary key, but of course this is configurable for the user. So if you have a set of other columns that you want to map the key to, you can certainly do this as well. But then we also provide you, as a part of this event, we provide you two different really key and important components. And the first component that we want to talk about is the before and the after state. And if you think about this again from the perspective of a relational table, you have your columns and you have your values. And the before basically represents what was the state of that row before the change took place. And of course, then the after represents what is the state of that row after the change occurred. And in the case of, say, for example, an insert event, you wouldn't have a before state, but you would have after. And then, of course, in the case of a delete, you would have a before state and you would have no after state. And we can go on to the next slide and we can see on this one where we have a couple of other components that are part of the message payload. The first here is the source block. This is really, really important because it provides you a lot of metadata information about where we sourced this particular event from. It could contain things such as the database, the schema, the table, maybe even the transaction reference. In the case of things like Oracle, it's going to provide you even more deeper metadata information about which particular node in the Oracle RAC cluster that event took place on. So you could really kind of use this information as you're going through and scraping the events that are inside your Kafka topic. You could really cross-reference every one of those events back to the transaction log on the database if you wanted to, using this information. And then we also capture things like, what is the operation type? Is it an insert? Is it an update? Is it a delete? Or is it something that represents a read event where we did the initial snapshot? And then, of course, things like, when did we process this particular event? And all of these payloads can be serialized to Apache Kafka or to any other messaging platform using a number of different serialization techniques, whether it be JSON, whether it be Avro. That's really entirely up to you, because this entire process is completely configurable. And that's really kind of the key at the end of the day. A lot of Debezium users are not programmers. They are maybe data analysts, or maybe they're a little bit tech savvy. And by really allowing Debezium to be completely configurable by configuration, it makes it so easy for people to really get started with it and to be able to capture these events. We also support being able to emit our change events using cloud events. If you're not familiar, cloud events is a somewhat standard technique for emitting events in a particular type of format. And so all of our Debezium events can be used with the Cloud Events Converter and configured as such to being able to emit those events using this specific format. And if you notice, it follows a very similar technique. There is an identifier at the top of the event. There are a number of different metadata key value pairs that are going to be paired as well in this event. They're going to all be prefixed with IO Debezium, followed by some additional descriptor afterward to describe what does that value represent, such as whether or not it's the schema or the table. A lot of these attributes, if you go back and you look at the previous slide, you'll see they're all mapping back to like the source info block. So there's a lot of that information is being carried over, but being carried over in a way that allows the consumer of that cloud event to be able to contain all of the information that we had, even if you weren't using cloud events. And then, of course, inside, yes.
Chris, sorry, a question related to this topic. That means that could be CDC can easily integrated or incorporated in a Knative workflow. Correct me if I'm wrong. So supporting easily cloud events.
It very well could be, yes.
Okay.
And I mean, and again, going back to what we were talking about earlier with Debezium Server and having Knative eventing as a sync option with Debezium Server really kind of enables this pattern very fully, because at that point you can run Debezium inside of a pod, capture those events, convert those events to cloud events, and then emit those directly into Kubernetes using Knative eventing as well.
Okay, cool.
And then if coming back to the cloud event, we have a data section, and this section very much mirrors what you would see if you were looking at this inside of a Kafka event. We have a section with a schema that describes what our payload structure looks like, what are all the fields, their respective data types. And then, of course, in the payload field, we have this before and after section that looks just like the previous event types that we would emit if we were not emitting them in cloud event format. So I guess I can also talk about here a little bit of some of the latest changes that we've made to Debezium. You know, we've been quite at work over the last number of major iterations of really trying to bring a ton of new features to the CDC platform. And one of the biggest new features that we added is a feature called incremental snapshots. And we introduced this in Debezium 1.6. And the idea here with incremental snapshots is that this allows you to be able to take a snapshot of your existing data concurrently while the connector is streaming changes from the transaction logs. This also has the benefit as well that this snapshot is resumable. So let's say, for example, you're running your connector, you're incrementally snapshotting your data, you're capturing changes from the transaction log, and you need to shut your database down for a moment to make some changes and then bring it back up. That snapshot is completely unaffected. The traditional snapshots in this particular scenario would require you to rerun the snapshot from the beginning. So that is one of the really huge advantages of using incremental snapshots with Debezium. But we've also improved upon this process in recent versions, adding the ability to being able to stop a running incremental snapshot, being able to partially stop parts of the incremental snapshot. Let's say you're wanting to snapshot 2 tables and you want to stop snapshotting one of those, but you want the other to continue. You have this option now of being able to do this. You could additionally choose to pause and resume those incremental snapshots. And there's also a new feature that was added, I believe, in Debezium 1.9 that allows you to be able to even apply a predicate condition to the incremental snapshot process. So if you want to only focus on capturing a subset of the data from a table instead of all the data again, you have that option and that flexibility of being able to do so. Some additional changes that we've also added in recent versions include adding change stream support to the MongoDB connector. MongoDB was originally written and implemented to read and to tell the op log of the database or the transaction log. And we have moved away from this in recent versions to using MongoDB's native change stream support. This provides so many more features than what the traditional oplog approach provided previously. In some recent versions, I believe in Debezium 1.9 or 2.0, when we introduced this, there is the ability to be able to capture the full documents of that change now. So there's tons of new features that came along with adding this change stream support for the MongoDB connector. And then just to kind of jump forward a little bit, in 1.9, we added support for multi-database support using SQL Server. This is really, really huge from the perspective of any environment where you have a single installation and the single database installation supports multiple databases. So you have this in SQL Server. You also have this in Oracle. And one of the new features that we added with SQL Server is being able to deploy a single connector to capture changes across multiple databases in that SQL Server installation. Previously, it required that you go through and deploy different connectors for each database, and now you can do this with a single connector. And the main benefit to doing this is we can really harness the power of Kafka Connect with its multitasking architecture, where we can distribute each of those databases across different worker nodes to being able to do that work in parallel instead of sequentially. And then, of course, starting with Debezium 2.0, Java 11 is now required. And we also have added a new feature for MongoDB 6 and later, which is being able to provide you what was the state of the document before the change occurred. And this is really starting to take MongoDB from this perspective of just being able to tell you what has changed or what does the document look like after the changes occurred, to really kind of moving MongoDB more to what that before and after state looks like and those change events from the relational connectors approach. So we're hoping that with some of this new features coming with MongoDB, that we can start moving in a way to where everything, even MongoDB, could be somewhat uniformly represented as a change event.
Exactly. Yeah, maybe the roadmap very briefly, because we have then also, like we said, 2 use cases that we want to show and maybe also a quick demo. But I think it's interesting to learn what lies ahead for Debezium in particular for next year and after.
Yeah, absolutely. So, I mean, just to highlight just a couple of really important ones here, we are looking at implementing our own JDBC sync connector next year, which is really, really kind of cool. The idea is to being able to ingest raw Debezium events. So if you've used other vendors' JDBC sync connectors in the past, you've had to flatten the Debezium events to be able to consume those. We're looking to be able to provide a way of being able to ingest those and write those to your JDBC database, or over JDBC to your database without having to do that process. We're also looking to bring MariaDB as a first-class connector. And then we're also looking at implementing things like exactly one semantics, which Kafka Connect and Kafka now support. So we're looking to do this in a multi-phase approach next year, starting with a couple of connectors initially, and then rolling that out to other connectors throughout the year. And then, of course, there's some UI improvements to our UI, Debezium UI component. We want to be able to allow you to be able to do things like editing a connector, being able to see some key critical metrics inside the UI, and so much more. So there's a lot of advancements and features coming for the UI next year. So be sure to check that out and keep an eye out on the release notes.
Sure. So with that, let's talk about now 2 selected CDC patterns to see how you can make use of CDC for doing something called the Outbox pattern, or then afterwards we look into another pattern called the Strangler fit pattern. But I think Chris briefly starts to explain the Outbox pattern a bit.
Yeah, sure. So with the Outbox pattern, we kind of touched on this a little bit earlier when we talked about microservices. As you're building up these microservices, the idea is that you want to be able to kind of keep these microservices in their own silos. We want them to have their own database. We want them to be able to morph and evolve independently of other microservices that might be participating in the topology. And in order to be able to do this, you're still going to need to have some kind of mechanism to being able to share data between those microservices. And one reliable way of being able to do that is with the Outbox pattern itself. So if we go to the next slide, what we can see here is we have this order service on the left, and we have some other microservices that are on the right. And we're using Apache Kafka here in the middle to facilitate this communication. And the idea here is that we want to be able to signal the shipment service to do something when we've done something with a particular order. Maybe when we save the order, we need to be able to tell the shipment service, hey, now go ahead and ship this order for the customer. But we want to do this in a decoupled way. And so in this particular case, even if Kafka could participate in a distributed transaction, which some people may come to this approach and go, well, I'll just do this distributed transaction and facilitate this kind of orchestrated transaction across these services. You really don't want to necessarily do that in the grand scheme of things. And of course, you also don't want to have this kind of dual write approach, because it's really prone to all kinds of inconsistencies. What happens if you write to the shipment service, but then the order service rolls back, or vice versa? So we really want to move to a pattern to where we can facilitate this type of communication in a very reliable way. And so if we take a look here, the way we can do this with the Outbox pattern is we can decouple this down by looking at what our order service is like first. So we have our business tables here for our purchase order and our order lines. And then what we're going to do is we're going to add a new table into this particular service called this Outbox table. And the idea with this table is that we're going to write to this table at the same time that we write to our purchase order tables. This gives us a local transaction. This gives us a transaction boundary that's specific only to this service, to where if something happens with writing the purchase order to its database, the write to this Outbox table would also be rolled back at the same time. And if it succeeds, then everything succeeds together. And then what we do is we introduce into this Debezium and Apache Kafka. And what Debezium is going to do is Debezium is going to be monitoring or capturing changes from the transaction log, but it's only going to be interested in this Outbox table. And what we're going to do is when we notice that there is a change in this table, we're going to push this change into a topic in Apache Kafka. And then we can allow our other microservices in this topology to be able to react to that event in any way that they need to do. And the Outbox table itself can have a variety of different tables out of the box. A number of different columns. Out of the box, the Outbox adapter expects these particular types of columns to be present, but this is somewhat configurable. But it really allows you to be able to kind of identify and produce what's called an aggregate, and being able to provide that information to those other consumers, whether it be a shipment service, whether it be a customer service or whatnot, in a real decoupled way.
Yeah, maybe you want to show that quickly in a demo, Chris?
Yeah, sure. I certainly can. Move this here. So can you guys see my screen?
Yes, let me
Yep.
enable it. Yeah.
Okay, cool.
So first of all, I just want to point out for those watching, we do have an examples repository where this particular Outbox example is sourced from. If you're ever interested in understanding how to use Debezium in a variety of different ways, there's tons of different implementations here, whether it be you're wanting to integrate with Camel, you're wanting to integrate with a cache, or you're wanting to do some kind of case streams or KSQL functionality inside of Apache Kafka. All of that stuff is here, so feel free to check out our examples repository, but we're going to be taking a look at this Outbox example here in particular. And what I have done is I have gone ahead and started up my Docker Compose file, and we can take a look at this here. Let me make this a little bigger. So what we have in our Docker Compose here is we have a couple of services. We're running Zookeeper and Apache Kafka. We have a couple of databases here. We have one for our order database and one for our shipment database. This again is mirroring that silo for the order service and the silo for our shipment service. And then we have Kafka Connect running. And here we're actually leveraging the use of Strimzi in conjunction with Debezium, of being able to run this together inside that container. And then finally, I have our order service and our shipment service. Now, these two services are using Quarkus to be able to provide a RESTful interface that we can interact with for being able to persist an order to that particular service. And then there is obviously some RESTful interfaces for being able to get the shipment data out of the shipment service in a true typical microservices architecture. And so what we're going to do is, like I said, I've started this up. I have all of those containers running, and I need to first of all deploy my Debezium connector. So the way I'm going to do this, I'm just going to register this JSON configuration with Kafka Connect. And if I scroll up here, I can take a look, and what I'm going to see is I'm connecting to my order database, and I am going to be monitoring or capturing changes from this Outbox event table. And I'm going to be routing those events using the Outbox transformation or single message transformation through into Apache Kafka. So if I were to pull up, I think I have it here somewhere. There's this image that we were just showing on the previous slide. What I have basically done at this point is I have set up my CDC with Debezium to being able to monitor this Outbox table, this component here, and being able to send those events into Apache Kafka here in the middle. So at this particular point, there's no data in my orders table, so I need to generate an order. So I'm going to do that by using the order services RESTful API. And I'm just going to create an order here. And if I scroll up here, you can see that I have created an order with ID 1 with a couple of lines here. I've decided to order 2 of the Debezium in Action, and I've decided to order 1 of the Debezium for Dummies books. And then let's say I made a mistake. I want to actually cancel one of those. So I'm going to cancel my order for the Debezium for Dummies, but I'm going to keep my order here for Debezium in Action. Now, the reason that I have done 2 different events here is I want to be able to represent from the originating side in the order service to the shipment service. I want to be able to show that I'm getting multiple events and how those events are being handled inside of those services itself. So let's jump over into our order database, and just to be able to confirm that all of our order information was written to the database, which we could see here in the log above us, but just to be sure, we can see here we have this order and we have 2 line items. And again, we can see that the Debezium for Dummies was canceled. We can see our Debezium for Action is still in entered status. And if I take a look at my Outbox table, we're going to see there's no data in this particular table. And that's expected. And the reason this is expected is because when you're working with the Outbox pattern, we're really only ever interested in the insert events. We're not interested in updating the events or updating rows that are in this table. We're not interested in deleting rows in this table. So typically when you're using this pattern, you're going to write a record to this table and you're going to immediately remove the record from the table, just so that you don't necessarily need any kind of housekeeping on the Outbox table over the duration or life cycle of your service. Now, some users may decide, well, I want to keep this data for debugging purposes. You certainly can do this and then purge this data at some future interval or on some interval. But that's completely up to you. You can do it as you see fit. It will have no impact on the actual delivery of those events using the Outbox pattern with Debezium. And then if I jump over into my shipment database, let's take a look to see what we have over here. I can see now that I have notified the shipment service. The shipment service sees that my order has been received here for customer 123. But I only see that there's one shipment here, but we did insert 2 records, or we did make 2 modifications, if you will, inside of the order service. Well, if I then select here from my consumed messages table, we're going to see that there are indeed 2 entries here in this particular table. What we can do is we can correlate these events back to what's sitting in Kafka. So if I go back to my terminal here, I can now go in. I think this is it. Yes. I can use Kafka Cat to be able to look at my topic, to be able to see what events were received inside Kafka. And again, this is the events that are being captured by Debezium, being read from the Outbox table and being sent into Kafka itself. And I can see that I have 2 events here. I have one event that begins with 266 as an ID and one event that begins with A5F. And if I go back in and I look at my shipment database, I can see 266 and A5F, which shows me that my shipment service has received both of those events from Kafka and has processed those and has manipulated my order inside the shipping service appropriately. And that's really it. It's super simple. It's all driven by configuration. It really keeps the business concerns of your order service completely separate from your shipment service. It allows you to be able to evolve your data model in each of those services completely however you need to evolve those. It also allows you to be able to define a message structure that you want to be able to use in your Outbox table to be able to communicate between these services. And that structure could be very, very different. And you can even evolve that structure over time as well without necessarily impacting one or the other service.
That's definitely cool. Because when we speak about microservice and data management, usually there's a lot of could be dangerous integrations, because you most of the time end up doing strange stuff to keep everything up to date. In this way, this is a great way to keep a complex things simple, make it really simple but effective sometimes. So
exactly. And the beauty about this is that the payload, like I said, the payload that you're sending or communicating between these microservices is really entirely user driven. So whatever you want this payload column to contain, you really can kind of, whether you want to share the data between these microservices as an aggregate, whether you want to send individual events to represent rows or whatever, it's really entirely up to you and your business requirements. But it really, it does keep everything completely decoupled and really allows for that evolution of a specific concern without impacting another concern in your architecture. Absolutely.
Super cool. And Chris, I was wondering, looking at this demo as well. So how was the world before change data capture? I mean, before Debezium, how the people were managing this?
I mean, it really depends. So in a prior life, we managed this using things like Microsoft BizTalk was a great tool of being able to do some of this kind of stuff. But it was a lot more complicated. People have also used things like camel, to do polling, to being able to,
Polling,
capture those
okay.
events and things like this. But then you look at other architectures of other applications. For example, in past lives, I've worked with Oracle ERP, and their particular example, in their scenario, they do try to approach this from a perspective of where your order entry environment is separate from your accounts receivable and accounts payables, right? So they try to have, even though all the data is within the same database, they do try to silo things as much as possible. And then they use things like interface tables, which is a very similar way of like the Outbox pattern of being able to put data into a table. You then have another process that's responsible for reading this table and ingesting it and manipulating it and importing it into another subsystem inside of the database or inside of that application. And so really this pattern, we've been using this for quite a long time. Even sometimes you might have even used this in old ETL approaches where you wanted to gather data across multiple tables and you wanted to present this data in an aggregate way to some consumer. So it's really an approach that has been around for quite a while.
But in a batch way, right? In a kind
Correct.
of a polling batch way. This is the event-driven way, which is the reactive way, if you will.
Exactly.
Cool.
Because that's the benefit of change data capture. You want the events to come to you. You don't want to have to go get the events yourself. And that's really one of the big benefits of using change data capture today.
Super cool. And you mentioned another pattern, right? This was the Outbox. And
Yeah.
There's another one.
Yeah, exactly. So looking at the time, I mean, we could quickly go through it. I think we
Slides?
can do that.
Yeah.
Slides very quickly, or also a demo. Let's see. I mean, maybe I just explain the basic idea, and we could probably look into a demo as well.
Yeah, no problem. I mean, we have 8 minutes, but if we go some minutes beyond the time, it's not a problem.
Yeah. So then let me explain it briefly on a couple of slides, and then I try to show you a demo for that as well. Okay.
Yep. Thank you.
Great. So the Strangler fig pattern. We mentioned that earlier, as well as the other pattern that we wanted to show you, and very often. So Chris already touched upon also microservice architectures a couple of times. And so sometimes we don't start with microservice architecture. Sometimes we have legacy applications. We have monoliths that we want to probably gradually evolve into a different architecture. And let's say we want to go from a monolithic application towards microservices. And the idea is we want to do it step by step. Usually we know from experiences in the field that trying to do a big rewrite in one go is very often just like not working out that well. So, and that means when you think about it, you want to extract different modules or components of your monolith into separate microservices. You need to find a way that the monolith and some parts that have been extracted already can temporarily coexist while it takes you to migrate the whole application. And that can be many years in certain cases. So this coexistence idea is very, very important here as well. And so here we have a very simple scenario. It's a monolithic application, and we assume that this is somewhat well structured in the sense that there are some components, some modules that in that monolith. So we don't assume it's a very bad, messy, big ball of mud architecture here. And then the idea is that we want to take out some of those modules, as they are called here, into separate services. And the way this works is that you first introduce a proxy that just routes all the read and write related traffic still to the monolith. At one point, then you start to implement a microservice, but that microservice needs some data. So let's say we do it for the customer module here, and then you would set up a Debezium change data capture pipeline that captures everything that is related to this customer module and propagates it further over Kafka into a separate database. And once you have that customer-related data there, thanks to CDC, you can start to implement that microservice that should work with that data. And once that is done, and let's say we also implement that microservice in multiple steps, we just serve read requests to begin with. We reconfigure our proxy that the read requests are now coming from the microservice and are not directed to the monolith anymore. And then once we have that, we can also say, well, we want to support write scenarios. So changes to this customer service module now living in its separate microservices should be written in the microservice, but that at the same time means the monolith and some modules over there might need those changes as well. And for that, we would set up an additional change data capture pipeline into the opposite direction so that we can bring the writes changes to the customer related data back into the old monolithic application. And so that is the idea. And you would do that for all those modules one by one, like I said, stepwise. And at one point, you can shut down either modules or when you are done with the whole migration, the whole monolith. So I have a quick demo here as well to show. Let me go into my command line. You should see that. So there are a couple of containers up and running here. And the idea here is, let me go to the browser once more because I have it open in a separate tab. So there's a proxy. This is Nginx that runs on localhost now. And that proxy will be used to do that redirection of traffic between monolith and microservice. And here we have chosen a deliberately old version of the Spring Pet Clinic as our monolithic application. And what it basically does is it, among other things, it manages owner data, owners of different pets. And this is backed by a MySQL database. So the first thing is we want to do is we want to have that owner's view and build that in a separate microservice. So for that, we will go briefly back to the and reconfigure our proxy. So Nginx, after reconfiguring, will do one thing. It will take us from the monolith and redirect us to a microservice. In this case now, when I search for owners, I'm redirected to, in this case, a Quarkus microservice. And of course, it doesn't find anything yet because it has no data yet. And this is what we are going to fix now. We are going to run a MySQL source connector for two tables here, for the owners and for the pets table. And because we have seen that on this view, this was not only owners data, they also showed the pets of the owners. And once we have that MySQL connector in place, we configured it to listen to two particular tables of this pet clinic application. We should be able to have one thing. Namely, the data is in Kafka, but it's nowhere else yet. So in addition to that, think about, we mentioned, usually we get our changes from tables into separate topics. And now we have an owners topic, but also a pets topic. And we need to find a way to bring those together so that we can serve a read view that contains owners and pets related data. So basically, we need to join those two topics together. And for that, in the background, we have another Quarkus application running Kafka streams. And what it does is it listens now to those changes and will join them. But first, let's see how the owner's data looks in Kafka. So we have seen this before. This is one record, one owner record from the MySQL database. It's an initial snapshot, so we don't have a before state here. And the pets data, they looks similar. So we have here another topic which contains the different pets of these owners, okay? And then we have, like I said, we need to bring that together in flight, basically. And for that, in the background, we have a Kafka Streams application running, written with Quarkus, and it joins these together. So what we then get is documents such as this. We have owner-related data here with all the owner fields from the database, and we have pets, which is an array. Of course, an owner can have multiple pets. And now that we have it in Kafka, what we can do is we can, in the next step, register a sync connector. And in our case, we say our microservice written in Quarkus that should take that data and serve read requests is running MongoDB. So we configure a MongoDB sync connector. And once we have done that, those pre-joined data documents make it over to the microservice. So now when I refresh, I have that same view that we have seen earlier in the Spring Pet Clinic monolith in my microservice here, together with the pets names. Okay, so let's quickly check one thing. If we want to edit an owner, we are brought back again by the proxy. It's a write request. We are coming back to the Spring Pet Clinic. Okay, and let's make a change here, John Doe, and write that data. We have John Doe written into the MySQL database, and in the background, this is propagated into the Kafka topic. The Kafka Streams job will do that, a join for us, and bring it to finally to the microservice. So let's just briefly check if that change made it over. And yes, you see it here. The change made it over into the microservice. And since we're about to finish because we are running out of time, that was basically just a quick idea of how you can use a CDC pipeline to feed specific data of a monolithic application into a microservice and its own separate database. With that, I mean, the demo has a couple of more things, but I think we are basically running over otherwise. So again, the idea is we can do the same thing for the writes path. We would just reconfigure the proxy once more and set up a CDC pipeline into the other direction. And then we could change our owner's data in the microservice, and we could propagate them back into the monolith again, thanks to Debezium. It would capture then the changes with the MongoDB source connector to Kafka, and then we have a JDBC sync connector that writes those back into the monolith. Maybe one last thing that we wanted to touch upon, if we have time, let me know. We could do that. Probably Chris wants to quickly tell a little bit about how Debezium is integrated into other parts of Red Hat products.
Yeah, absolutely. So at Red Hat, we do have a number of different products that are either currently in development, going through initial preview, or are part of commercial offerings. Some of those include the OpenShift streams for Apache Kafka. We know mostly internally, I believe, as ROSAC. So this is pretty much where we are exposing a fully compliant Kafka broker environment for users to be able to interface with and to use any kind of connector to being able to send and to consume events from an Apache Kafka environment that's managed by Red Hat. We also have the OpenShift connectors environment and or OpenShift connectors solution, which is actually using the Debezium connectors as well as the CamelK connectors in order to be able to capture changes from various different sources and to propagate those changes to a managed Apache Kafka environment running on Red Hat OpenShift streams for Apache Kafka. And then, of course, there's the Red Hat integration. This is a stack built on AMQ streams of being able to integrate your applications across a hybrid infrastructure. It allows you to be able to compose and to orchestrate and transform any kind of data using CDC and cloud native platform to support any type of modern application. As I said, Debezium is bundled here as a product offering to being able to provide reliable and flexible real-time integration and messaging.
Great.
Great.
It was
awesome.
a really awesome session.
Yeah, really. We've seen two very cool live demos, and the example for the demo, correct me if I'm wrong, are in the repository we shared before, right? In this one.
The Outbox pattern is, I don't believe the Strangler fig pattern is there, but we could certainly look at adding that in the future. That shouldn't be a problem.
Thank you.
Exactly. So the Strangler fig comes in its own repository that I did for a conference talk previously, but we can share it afterwards as well.
Yep.
Fantastic.
Okay,
thank you.
Cool.
So call to action to anyone is going into the Debezium website to discover what is the Debezium, download Debezium, run Debezium in your Kubernetes in an OpenShift. There's an operator for Debezium, Chris, Hans-Peter, so people can install Debezium in the cluster.
There is. You can use Strimzy to being able to deploy a Debezium with Apache Kafka Connect.
Oh, wow. So you can basically deploy Strimzy operator. You are able to have Kafka and Debezium.
Yes.
So you can test all those example, the Outbox pattern, Strangler pattern. You have in the repository, you have some of the examples. And hey, folks, today we've seen live demos. And Chris, big shout out to you for live demos early in the morning. That was super cool. Thank you. Beers
for
are
having me.
on us when you come
Kudos.
over here, or we
Yeah.
met at a conference.
Soon.
Sounds good.
But Hans-Peter, your demo is super cool. I mean, I like it. Also, the bi-directional pipeline for the read and the write. This is a really cool, real example, right? So looking forward to see this also in the example directory, because it's super cool example demo to show. So folks, thank you both for joining us today. It was a pleasure. We would like to have you back for any update on Debezium and when you want to come. And Fabio, our appointment today is OpenShift TV in the afternoon for us,
There
in the
will be
morning for US.
Big announcement today also. What's new on OpenShift?
Yeah, please don't miss the what's new on OpenShift today at OpenShift TV. You will find it in the OpenShift TV official schedule. We will come back, Fabio, next week with an episode with Dynatrace, with OpenShift. We're gonna have some folks on Dynatrace. So see you next Wednesday, same time, and please stay today connected to OpenShift TV for the what's new. So what's new in the next version of OpenShift. Thank you again.
Have a great day.
Folks. Have a good day and talk soon. Ciao.
Thank
Cheers.
you.
Bye.
Bye-bye.
Bye.